Today we're going to look at one of the last of the two distributions we're going to be doing. So we've done quite a lot, right? But the last two that we're going to do are very easy as long as you pay attention, yes, and think about what's happening, okay? So today we're going to talk about the rectangular or one of the continuous, because in reality the normal distribution is also continuous, right? It doesn't have any breaks in it, it just moves on. But the rectangular distribution is even more continuous. You're going to love this one because of the shape it takes. So think about this. When we're doing normal distribution, what we were finding when we found one of these things is the area under the curve. Right? Remember they kept saying area, and then they finally, when they gave some of the others on the last ones, when they're doing inverse, we even had to put in the area. Okay? And so the area under the curve is the same as the probability for that particular event. Yeah? So we can define area of the distribution is equal to the probability that x equals whatever you're looking for. Yeah? So the space that it takes up is the same as the probability. Yeah? So if that's true, then we can use a little bit of geometry, super easy geometry, to find probabilities if the distributions are distributed in a geometric shape. And since these are rectangular distributions, all we're doing is finding the area of the rectangle that we need. Now, anybody remember the area formula for rectangle? Area equals what? Length times width, right? And it doesn't matter which one you call length and which one you call width. You can mix them up as much as you want to. It makes no difference. Yeah? So we're going to use that definition, length times width, to be able to find the probabilities that we need. Okay? So let's go to the book and look at some pictures, because these are much easier to see when you have pictures. Okay? So the rectangular continuous uniform. Continuously uniform because it never changes. It's just a flat line on the top, right? So characteristics. Remember that the difference between achieved and merit and excellence is describing what's happening here. So they always start with the characteristics. It's a continuous distribution. In other words, it flows on. There's no gaps in it, right? That's what continuous means. It takes the shape of a rectangle because the probability is the same at all intervals. So the probability doesn't start off small, get bigger, and then get smaller like at the normal distribution. It's always the same, straight across. And you can use it. How do you know you're going to use it is you have the following information. You have a maximum and you have a minimum, but you have no mode. It doesn't tell you mode. And we're not going to worry about that too much right now because we're going to look at triangular distributions, and we'll talk about mode then. But the maximum and the minimum are given. So, all right? So let's talk a little bit about the pieces of this. So they give us an example. They give us an example. A tug-of-war rope is equally likely to break at any point between the opposing teams, right? So you have a piece of rope, right, stretched between two teams, and it's equally likely to break at any point along that distribution. So we've got a straight line distribution, right? Do they usually do tug-of-war on the ground? No. It's held in the air, right? So from the ground to the top of the rope makes a rectangular shape. So the distribution of this will be a rectangle. So let's look at some of the parameters. We have A, which is one end of the rope. We have B, which is the other end of the rope. And how could I calculate the length of that?
The distance between A and B.
You betcha. And we always subtract the smaller one from the lesser one, right? So the lesser one from the largest one. So we take B minus A. Yes? Now, so that gives us our nice rectangular distribution. Okay? So if this thing is the same height all the way across, that means that the probability underneath it never changes. It's continuous throughout. Now, but in order to find the area of a rectangle, remember, I need a base and a height, or a length times a width, however you want to call it. Makes no difference. Well, the base is easy. The base is just found by subtracting these two. So it's just that length. Yeah? The height you can find if you'll remember that all probabilities, the total area of that thing inside has to be 1. Yeah? And we're going to be multiplying two numbers together to get 1, so we need the reciprocal. Do you remember that term? If you don't worry about it. They're not going to ask you for that word. But reciprocal just means some number that gives a product of 1. Now, if you don't remember that, don't worry about it. We'll just do it their way. But I just want to show you where this number is coming from. So let's say that our length was 5. Well, what number, and the reciprocal is almost always a fraction, what number can I multiply 5 by to turn it into a 1? 1 over 5, right? 5 times 1/5 is 1. Any fraction is the same way. So what's the reciprocal of 6? It's the reciprocal of 12. Reciprocal of 52. Don't put equals, put an arrow or something, because they're not equal. They're reciprocals. And if you multiply anything times its reciprocal, you get 1. And it has to multiply out together to give you 1 because all probabilities always combine to make 1. So the area of that rectangle always has to be 1. So that's what they're doing here with the height. They're simply saying find the reciprocal of. Okay? So it's just 1 over whatever this number is you got down here. Always. So you're going to have to memorize that, though. We'll look at your formula sheet and see exactly what they give you, but probably not going to give you most of it. All right. So that thing is the height, and the base is simply whatever that length is. Okay? And together, added together, multiplied together, they have to give you a 1, and that's why we use the reciprocal. Is good? That's all the math there is here, pretty much. Okay? If you know the height of it, and you can do some subtraction, then you can find these probabilities. So let's look at a couple of examples just to show you what's going on. Don't worry about this formula, that's dumb. Okay. Now. Pardon me? Well, that's the mean. Don't worry about that. We're not there yet. Okay? So let's just look at an example. Company A requires that all employees work for 40 hours per week, of which a minimum of 10 hours must be spent in the company office. The remaining time can be spent working from home. I wish. Okay. Calculate the probability the employee spends less than 15 hours in the company office. All right? So, everybody works the same amount of time, yes? So that means the probability for every employee is going to stay the same throughout the whole time. Do you agree with that statement? We've got a maximum amount of hours and a minimum amount of hours that they have to spend. So let's look at our rectangle here. They have to spend a minimum of 10 hours in the office. Yeah? So that means that we're going to start out at 10 and then go up to the 40, because they could spend more time, right? But they have to spend the minimum of 10. So here is our rectangular distribution from 10 to 40. Okay? Now again, we're not worried about 1 through 10 because everybody's doing that part, right? We're just talking about how much additional time do they spend in the office. Now, this particular person is going to, we were talking about the probability they spend less than 15 hours. So what we're going to do is we need to find the difference between 10 and 15. That's the probability we're looking for. So this little rectangle is the area we're trying to compute. And remember, area is simply base times height. They're using base times height, and I will too. I usually use length times width. Now, first of all, though, I need to know this total distance across the bottom. And what is the total distance across the bottom? 30. And I need to know the height, and the height of it is just 1 over what? 30. Whatever number you get at the bottom, 1 over is the height. Okay? Now, they changed it to a decimal. You don't have to worry about that because you're going to use your calculator, right? Now, you're going to change your answer. You're going to give your answer as a decimal. But it's better to multiply with the fraction and then do the rounding. Because if you change it to a decimal first, you're going to have to round first and then multiply, and that's going to introduce some weird stuff. So multiply with the fraction. You have your calculator. You can do that. Now, so all we need to do, but I'm not looking for the entire area because I know that if I multiplied 30 times 1/30, I would just get a 1. Yes? So I'm looking for just this little bit of an area, which is the area between 10 and 15, which is how much? 5. So my base is 5, and the height is 1 over 30. And to get the area, all I need to do is simply multiply those together. And can anybody give me that as a decimal rounded to 4 decimal places, please? Yeah, you won't need to round it to 4. It's going to repeat. Somebody? Anybody? Supposed to have those calculators out, remember? So what you get is 0.16 repeating, right? So we're going to round that to 4 decimal places. Gives us area equals 0.1667. Now, they wrote it as 1/6 with a dot over it, meaning 1/6 repeating, but we typically use probability as 4 decimal places, right? Rounded to 4 decimal places. Okay? Fractions on your calculator. You should have an ABC key, right? Do your calculators have that? Hold on. So in your case, because you're not looking for a fractional answer, you're looking for a decimal always, you could just put 1 divided by 30. Do that first, then hit equals, and then times 5. Right? So you can just use 1 over 30. 1 divided by 30. Because remember, the fraction bar means to divide. Yeah? And that's all they did to get this number. But you don't need to write that number down. You could do 1 over 30 is just as easily. All right? And that's all we're going to do is find those. Now, but you'll mention, but also one other thing that they mentioned a little bit earlier, though, was the mean. Let's look at this, too. They may ask you for the mean. Guys, shh. They may ask you for the mean of the rectangular distribution. Remember that mean is usually the sum, but we just need a distance. So in other words, the mean is simply the point halfway between, right? Well, to find halfway, you just take the number and divide it by what? 2. Divide by 2 to get the halfway point, right? And that's what they're doing here. So the mean of any of these, because they're exactly the same, right, all the way across, the mean is just the middle number. So if they ask you for the mean. So let's see what else they ask you for and see, and then we're going to set you free doing cubes. The 20% of the employees who spent the most time working at home do not qualify for a desk of their own. What is the maximum length of time that an employee can work at home each week if they wish to qualify for their own desk? So again, don't worry about all the nonsense that they're doing over here. You just do your shading and you can get this. All right? So that means the top 20%, okay? Well, this one you'll have to do a little bit of an equation because you have to do a little. So the top 20%. Now the problem is I don't know that number. So I can't subtract it, can I? Right? So I'm going to have to make an equation out of this. So let's talk about what's happening. Again, the distance all the way across is 30. Yes? Okay. The height is 1 over 30. But this time, so this is an inverse. I know the area. I need to find the x value, well, in this case they called it y, but x is usually what we call all the others, okay? So think about what's going on. So normally it would be the largest number minus the smallest number, or minus your x value, I'm sorry, over 30. Because you would take that difference of those two and multiply by 130. Right? But we don't know that top number, do we? Because this time it's an unknown. So that's where they're getting this equation. So let's just write it like we did before. So the base that we need, well, in this case it's the largest one because our shading is up here, right? So the base is 40 minus y this time.
Huh? Oh, wait, hold on. Okay,
Right? Because we want that distance. To get the distance, you just subtract them. But we don't know what that number is, so we're just going to call it y. Our height, H-E-I-G-H-D, yeah? H-I-E? Oh, well, who cares? Thank you. It's not an English class. Okay, our height is 1 over 30. Right? That didn't change. So, and we know that the probability, or our area, is 20%. So this time they gave us the area of 20%, which we will change to 0.2. Well, from that, we can now form an equation. And that's what they've done here, but they've done it in a funky way because they put the probability statement in it. But just think about what the equation is. Area,
Sorry, what was P again?
P, probability is the same as area, right?
Oh.
Right? Because the area is probability. So area equals base times height. Do we agree? All right. So what's our area?
0.2.
Equals, what's our base? 40 minus y. Now, you're going to use, if you want to use solver or you want to solve this by hand, but I'm going to show you how to use solver, but you can certainly solve these by hand. They're pretty easy. And if it's y, we're just going to call that an unknown, so we'll just use our x key, like we did for standard deviation and mean and everything else. And why did I put it in a bracket? Because I need the entire thing to be multiplied by the height. Now, instead of multiplying by the height, they showed it as division. And the reason for that is because the height is 1 over 30. And when you multiply 1 over 30, that's the same as divide by 30. Okay? But if you were entering it in your calculator, you could just enter it as 1 over 30. And that way it looks like all the others that you're doing. Now, you could put this in solver and solve it, or you could solve it by hand. Which would you think you'd do? Calculator, solver? Okay. So if you do that, all you have to do is remember that you need to put this in brackets. All right? So put it in solver. Do 0.2 equals, remember equals is shift dot, or shift period. Then put 4 minus, and of course you'll use x here instead of y. Don't go searching for those letters. It won't work. Just use the variable x. And then put that in brackets, and then times 1 divided by 30. And anybody want to tell me what you get? Yeah, just use your x. Use your variable x. Hold on. All right, let's look at it on paper, guys, so that you can see it without all the junk. All right. So, we need a base. Shh, guys. We need a height. Right? Our base, we would normally just to subtract the two numbers that we have as boundary points, right? But this time, one of my boundary points is an unknown. Now, my height, the whole thing all the way across is 30, so that means my height is still 1 over 30, right?
Why do you choose 40?
Because it's not the height.
It's the largest.
That's just the area we're looking for is between 40 and y. Okay, and that's why, right? So that was one of our given values. Now, so my unknown is in the base. That means I've got to form an equation. And so what's the other point we're looking for? Make fun of me. The area is what we're normally looking for, but this time we know the area. It's 0.2, right? 20%. So And the formula is area equals base times height. So what we're going to do is plug those numbers into the right part of the formula. So area, 0.2, equals our base, which is 40 minus y. And because it's two terms, anytime you have two terms as one of the pieces, it has to be in brackets.
Well, I don't know what you're saying, but yeah.
Do you see that it's two terms? Yes? Two things. It's a 40 and a y. Times, and our height is 1 over 30. All we're doing is plugging in the given information in the right spot for the thing. Okay? And then we'll work it out. And we should get that y equals 34. Remember, you have to hit execute twice. Okay, so this time, employees are expected to work 45 hours, and everybody spends the first 5 hours in the office, which is why we don't care about that part. Okay? So it's from 45 to 5, which is a distance of what? 40, which gives us a height of 1 over 40. Every time. Find that distance on the bottom, and then the height is always just 1 over that number. Okay? And so here is our new probability distribution. Now notice it's not as tall as the other one because 1 over 40 is smaller than 1 over 30. Do you care?
No.
Only if they have a scale up the side do you care, right? But if they don't have a scale on the side, you just sketch it. All right? So do you see the changes? Does that make sense to you? Let's look and see if they give us a question about that. Nope, the question was just to sketch it. All right, so let's do one of these from start to finish. A rectangular distribution has parameters of A equals 4 and B equals 12. Now remember, A and B are those numbers where? At the bottom. It tells you how long it is. Yeah? Show that the height of the distribution f of x equals 0.125. Well, all you do to get the height is take B minus what? B minus A. So what's 12 minus 4? 8. Now, okay. And then the height is 1 over that number. And all I have to do is show that 1 over 8 is the same as 0.125 by plugging it in my calculator. Plug in your calculator, what do you get? Anybody? So you'd put A is 4, B is 12. So 12 minus 4 gives me a distance of 8. So the height is 1 over that, which is equal to 0.125.
Wait, how does 12 take away? Oh, wait. Never mind. I'm so sorry.
Fun. All right, so here we go. So all they're asking you to do is to prove that this distance, the reciprocal of that distance, will simplify to that decimal. Does that make sense? And the only reason they make you change it to the decimal is they think that the decimal is easier to put into your calculator and work with. But it may be for some of you, it may not be for some of you. Who cares? So we now know our information that we need in order to be able to draw the graph. So here we go. Sketch the distribution on the axes below. Now notice they didn't give you a place for height, did they? So who cares? We're just going to sketch it. Right? Now, you could put in values here. I mean, you definitely have to put in values across here. So what was our A value? 4. So 1, 2, 3, 4. Yeah?
Why?
Now, did I have to put 4 there? No. Watch what else I could have done instead. 2, 4. You can use whatever scale you want to. So if you can count in ones, you can count in twos. If the numbers are very big, you don't want to count in ones, right? In this case, counting in twos might be better. But if you, right? 6, 8, 10, 12. Okay? As long as you are consistent, it makes no difference. Now, going up the top, we have 1 over 8, right? So I could count in fractions up the side, or you can change that to 0.125. Okay? If we assume this is 1, that's too big, isn't it? So let's think about getting a scale for this side. What do you want to use to make it? 0.125 is pretty small. Yeah? Okay? So if we did 1, we put it down there somewhere. That's a really tiny rectangle. We don't want to do that. So we could just put, here's what we'll do. We know that 1 over 8 is the same as 0.125. So let's just call this 0.125. That just means that if I got more of them, I would just add more, but I would have to do it. So this one would be twice that if I had to put more, if I had to change it. Yeah? So they didn't tell us what scale to use, so we can use whatever we want. So let's draw a rectangle. And remember, the scales on the bottom and the top don't have to match. So there's our distribution. Okay? So again, you can use whatever scale you want. Just make sure that whatever scale you use on the bottom is consistent, and whatever scale you use going up or down is consistent. Looks okay? All right. Let's see what's next, what they do to us. Show that the probability that x is between 6 and 9 is equal to 3.75. Okay? So x is between 6 and 9. So in other words, this time, it's not at... So we said this was 4, right? So 4, 6, 8, 10, 12. This is 12. This is 0.125, right? Now, so here's our distribution for the entire rectangle. But we don't want the whole rectangle. We want between 6 and 9. Well, 6 is right here. And 9 is in the middle there. So we're looking for this area right here. Now, I don't care that it's 6 and 9, because remember, it's rectangular, so it's always continuous across every part of the interval. So who cares? I just need a base. And from 9 to 6, that means the base of my rectangle is 3. And I need a height. But the height never changes, does it? So the height is 0.125. Which is going to give me my area when I multiply those together. Anybody?
0.375.
And you're done. They didn't give us any units here, so no. But if they did, if they said it was like the rope while ago was so many meters or something, yes. Thank you for that. Okay? So the math here is super easy. If you can do a rectangle, the area of a rectangle, you can do this probability. Now remember though, if you're working backwards, you still need a base and a height and an area, right? It's the same for all of these rectangular ones. Base, height, and area. And then you can have unknowns. It makes no difference. Okay, so what we're going to do is we're just going to look at the ones in the book and work on these. So let's see. These go through from page 97 to 97 to 101. So page 97 to 101. Now, you're going to notice here that just like last time when they gave you one, this one is not exactly. So that what they're going to do is they're going to want you to read it and answer the question, and then turn it into a rectangle and answer the question. Okay? Now, turning it into a rectangle means you're just going to be estimating, right? There you go.